Hi there everyone, welcome back here to We're Yacht in the Loft with me, Jenny Kirk. It's really great to have your company and I'm looking forward to showing you a special project today that has been made possible through our sponsor Train-O-Matic, and they supplied the Super Power Pack and also their 8-pin decoder that's compatible with that through SPP solder pads on them. And with these we're going to do a slightly unusual project. They say it can't be done, but myself and Train-O-Matic beg to differ. This is a split chassis Bachmann locomotive, the Class 4. It's not been in their range for a while, but it's certainly a long-lived model. And, well, there it is, working on DCC. So, if you're interested in seeing how to get your old split chassis locos to work this well, look at it go, then stick with me and we're going to be doing a full conversion of this locomotive using the Smart Power Pack and also the 8-pin decoder from our sponsor Train-O-Matic, who make DCC decoders and accessories designed by enthusiasts for enthusiasts. These are intuitive to use and effective in their results. Come with me and let's do this project. Now these are pretty troublesome when it comes to DCC decoder fitting, not least because the design of the way that they pick up power makes it really difficult to actually have a point to solder wires to. Now this particular example is the Bachmann Class 4 diesel shunter. It's got a split chassis in there and they actually work reasonably well on DC, although as they age they can sometimes become a little bit finicky. Now Bachmann's completely done away with the split chassis models in their range, as have other manufacturers, and one of the main reasons for this is because of issues with contact surfaces wearing out, with a difficulty in actually DCC fitting them and bringing them up to date. A bit like in a way that tender drives had their day and now they're considered inferior, so split chassis are considered very much inferior. Now we've had a completely retooled Class 3 from Bachmann, but the Class 4, well, we're still waiting for that. Now, it may well come, but there's an awful lot of the older models on the market, and outwardly at least, I think they still look the part. So what I'm going to be trying to do today is to show you how to DCC fit these safely in such a way that you don't blow your decoder and that the locomotives actually run reliably, and in doing so show you that older locomotives aren't necessarily destined for the scrap heap in this day and age of DCC fitting. Now I'm going to put this locomotive to one side and I'm going to bring in the one that I've already dismantled. So over here I have got a whole assortment of bits and pieces, and I've already been doing a little bit of preparatory work on this. And this model, as you can see, there's the top for it, is pretty much the same model. This is just a slightly different running number and factory weathered edition, but that doesn't actually make any difference whatsoever to the DCC fitting process. So I'm going to put the top out of the way, and you can see that I've dismantled all of the innards of the locomotive. So we've gone from the full locomotive there to the split chassis, and when you hear people talk about a split chassis, this quite literally is it. The chassis itself is in two halves, and they're separated by kind of plastic spacers, and the motor just loose fits inside there. So you can see this just sits in there, and when it comes to dismantling this, it literally just lifts on out. Now, what we're going to have to do is find a way of fully isolating this locomotive from both sides of the chassis. They're still going to be effectively the pickup from the wheels, which I've got here, and you can see these are on plastic axles such that each wheel is separated by that length of plastic, and the pickup comes from these sides of each wheel rubbing inside. You can see the shiny spots in there, just rubbing in there, and that's how it's picking up. So first up, I'm going to clean up all of this. I'm going to use a little bit of toilet tissue with some white spirit to get any trace of dirt and grease out here. And the reason for this is I'm going to start work insulating where the motor goes, and I don't want that insulation tape to be able to come unstuck and then move about and potentially cause the locomotive to end up with a short that could blow your decoder at worst, or at the very best just stop things from working. One of the other things that I've done initially is, you can see a little shiny spot there. I've drilled a hole into the chassis on each side, and I've screwed in a metal screw, cut it off, filed it flat, and that's become a soldering point for the actual pickups to the decoder. And the reason for this is that the zinc matte casting, you just cannot solder to this. It does not take solder, so you're not going to get a good electrical continuity if you don't do something like that. I utilised a couple of holes that were already in the chassis and just wedged a metal screw in really tight, and then cut the head off, and I've already tinned these with solder, so they're ready and waiting for our pickup wires from the decoder. So let's go and get that toilet tissue and the white spirit, and let's get this all cleaned up. So I started work on isolating the motor. Now, the two tabs that would otherwise have pressed against the actual sides there, they're going to be the soldering points for the DCC decoder. I'm going to get them quite easily soldered up, and then I'm going to use some more electrical tape just to separate them from being able to push against the sides of the casting here, and that should hopefully sort out any problems with the motor being able to short out direct to the chassis. Once I've done that, then I need to turn to also connecting the motor up to these soldering tabs. But before we get even down to any of that, I'm going to bring in the DCC decoder setup that I'm going to be wanting to use on this. So I have chosen the Train-O-Matic Locomotive 2 series DCC decoder, and I've gone for the 8-pin chip simply because this is about the cheapest in the range, and you don't need all the functions. There's no lighting on this kit. It's just simply a case of we need 4 of the wires from this decoder. Now, one of the other things that I really like doing, and it's something that since I discovered these smart power packs, I'm going to try and fit a smart power pack in as well. Now, in the range, there's a couple of different sizes and form factors. You can see here, this one is intended for N-gauge locomotives in the main. It's got slightly less power, but it's a different form factor, really good for fitting down inside the barrel of boilers, for example. And then we've got this, the slightly bigger, slightly chunkier one. It's not quite as long, but it's somewhat fatter. So what we're going to have to do is work out how best to fit these within the confines of the cab of this locomotive. We don't really want the electronics being visible if we can help it. So we've got here, this area here is inside the cab, and what I can see is that the decoder will kind of fit in there, and I'm going to open this up and I'm going to check out the smart power pack. I'm going to see just what we can do with this in terms of fitting into this space. And you can see there that actually fitted in upside down, that might not actually be too bad, and we can have the decoder fitted in somehow next to it or on top of it. So we may well end up with a little bit of decoder visible to the inquisical eye, but I think we're going to be all right, and anything that doesn't quite look right we can hide with a little bit of black tape, just like we did with the Lancashire and Yorkshire Pug project. So before we go any further, I think it's time to fit the Smart Power Pack to the actual DCC decoder. Now, I get asked a lot about the soldering, and actually soldering's not too difficult. So rather than do this as a time lapse or here's one I made earlier, just for you guys, I'm going to go through the whole process of soldering this up. And I'm going to bring in my trusty soldering iron. This is an RS Components one, I believe. It's quite old, but it does the job just fine. So I've got myself a pair of needle nose pliers and also a pair of wire cutters, solder, and also over here I've got quite a sharp craft knife too. So first things first, you'll see on the decoder itself there's actually a heat shield, a very clear heat shield, and what we're wanting is those 3 tabs there. So the first thing I need to do is actually remove some of that heat shield just so that we can start soldering to that. And just be a bit careful. You don't want to actually cut into the surface tracks because you could end up effectively negating the contact with these pads. So we just need to, I think, just slip the knife in very carefully. Don't really want to stab ourselves. And just try and peel back some of this. Take your time, no point in rushing. No point at all in rushing. I'm just going to try and peel that up out of the way and cut that off. Right, so we've cleaned off the heat shield just there, and that's going to let us tin those contacts, and that's what we need to do first. So what I like to do is just to make sure that we don't end up with this moving around whilst we're working on it, I just rest the needle nose pliers there like that, and that allows me to now get down and into there and tin them. Soldering iron's up to temperature, you can hear it clicking. Damp sponge, just try and make sure everything is nice and clean. And then what we're going to do is get a little bit of solder onto those tabs. So there, what we've got is we've got tin solder on those 3 tabs. So we'll put that to one side, and the next step, we need the 3 wires for the Smart Power Pack, and they're already tinned on there. They come out of the packet ready to kind of go on. I'm just going to tin them a little bit more just to make sure. Right, so we've now got these wires tinned, and we're going to be ready to make the connection. So we need to make sure we get the wires in the correct order. The order to do this is red, white, black, going from the edge inwards, red, white, black. As I've started up, I've got the white one to the middle, and what we need to be very careful about is which way around these other wires go. And I like to use this just to keep everything flat. The trick I find is melt the solder on the tinned wire, and then when that's still melted, just press it down into the solder tab. A quick blow on that just to make sure that we don't have excessive heat. This can be tricky, I'm not the world's greatest solderer. And then once that's on, we go to the next wire. Again, if you need a little bit more of the flux, just a tiny amount from the reel of solder. Melt the solder on the wire and then press to the tab. And that is in place. So what we're going to do now is I'm going to bring in my emergency spare chassis. It's just that old Class 17 chassis that you saw in the video about fitting the Smart Power Pack into the Hornby XL&Y Pug. It's really useful before we start trimming wires, just to make sure that all is working well. So I'm going to get this on the programming track and we're going to make sure that this works as intended. So we've got the locomotive now on the track and we're going to give that a little bit of power, and just have to be careful because everything's a bit loose. It should have had a chance to charge itself up by now. So you can see the motor's spinning, and lift it off the track, and yes, everything is working as it should. So what I can do now is we can get on and start soldering this into the split chassis locomotive. So that's the difficult part done, I hope. We can now remove this plug and pair back the wires, ready to go. As a reminder, one more time, red to the outer edge, white in the middle of the 3 wires, and then black there. If you get it the wrong way round, the chip will still work, you'll still be able to program it, but you will get nothing from the Smart Power Pack, so do be advised about that. Although hopefully it won't actually blow the Smart Power Pack, but until you reverse the red and the black wires, put them in the right way round, then you're not going to get any benefit from that Smart Power Pack. So the next stage I want to do now is I'm going to start work on getting these wires sorted. Now we only need the black, the red, the orange and the grey. Those are the 4 wires that we need. So it's black and red, they go to the track, and the orange and grey, they go to the motor. So what I'm going to do is I'm actually going to give myself as much length of wire actually on this one as I can. So I'm going to cut that plug off there. And then the next thing I want to do is make sure that we have the full length of the orange. And I want the red. I want the black and the grey. So let's just try and separate all of these out. Can be a bit tricky. So there. Those are the 4 wires I want to keep. All these others, I'm going to trim them there. Trim them down even further. So there we've got our 4 wires that we need. I'm going to start bearing the ends. So just very carefully, gentle pressure. You don't need a lot of pressure, otherwise you'll just end up shortening the wire. I'll put a little bit of a twist into each of those wires just to keep the strands together. And then what we need to do is tin the ends of these wires, because that just makes things a lot easier when we come to doing the next bit of soldering. And also bringing in the 2 halves of the chassis, and I also want the motor, which we've already prepped up. We've got the 2 contacts there and there. So red and black go to the track, orange and grey power the day. That's how I try and remember it. So let's get these wires tinned. orange and grey go to the motor. So I'm going to get a little bit of solder there onto the soldering iron, and then get these contacts tinned a little bit. And there we've got our connections to the motor. And then we need two. Right. This is where things start to get a little bit fiddly. So we need to make sure that those contacts on the motor are insulated now from the chassis. It's got a sharp bit of solder there, so just going to see about fixing that, otherwise it's going to push through the insulation and we don't want that. Trim that down a bit. So what I don't want is for that to just foul the end of the armature. So the next step, I'm going to try and fit this back into here. Okay. So now we need red and black. I'm going to solder these to the chassis. As you can see, it can get a bit fiddly. These wires seem to love getting in the way. So hopefully we've got a good connection between all the different parts here. So we're going to have to now try and get all of this back together. A lot of this is going to be a case of holding various bits in the right place and kind of a juggling act. So first things first, I'm going to need to insulate where the solder is, because they're going to effectively butt up against each other. So piece on there, and I'm going to double up just to make sure, with a piece on there. So very carefully now try and get the whole thing back together. Let's just go careful, 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 careful. Now the first problem that appears to have come up is we've got a protrusion with the soldering. So, yeah, you can see there, that's going to cause us a dead short. So, this is going to need a little bit more work, I think. So, not to worry. One thing that we can do is try and find a different location for one of these wires. A lot of this is, in some respects, trial and error. Now it looks like I might just have this cracked. So I need to get these back into place. And then it's simply a case of trying to very carefully reassemble all of this. That does look like we may have got that to go all the way together. So I've got my screws, and what we're going to do is very carefully, don't want to force these, because otherwise you run the risk of shearing the plastic and then it just won't go together. So let's get screws in loosely first. Right, we're now at the stage where we can start thinking about reassembling the running gear so that we can actually test this. And the first thing I'm going to do once we get to that stage is to actually just try and read back the decoder number from the test track, and that should tell us if all is well. You don't want to just put it straight on the track. If there is a short, that'll blow the decoder, but on the test track it's not going to do that. So I'm going to go ahead now and get those wheels back on. So there we have it. At the moment, the decoder and the smart power pack are just trailing a little bit, but that's fine. We're going to test this and just hopefully, fingers crossed, this is now going to work. So we've got the locomotive on the programming track. We're going to let's try and get it to read the chip first of all. So we should have 2267. Let's see. And 2267. Yes! So that means that this split chassis locomotive should now be good to test on the track. So let's get it put on the track and just see how it runs. Let's just bring the power up. And there we have it. I've just got the smart power pack temporarily strapped on with a piece of tape to the top just so I can run it. There you have it, a split chassis Bachmann Class 4 shunter DCC chipped with a smart power pack, which should make that an incredibly reliable runner. So I'm really pleased with what I've achieved there. One other important thing to remember is that CV29 needs to be set to 10, otherwise the Smart Power Pack will not work. So what I'm going to do now is get all that fitted into the cab of the locomotive, get the lid of it back on, and then we will have a finished Bachmann Class 4 shunter, fully DCC working. And there we have it, our completed locomotive with Smart Power Pack, DCC fitted, and yes, this is a split chassis locomotive. I'm very pleased with the results, and all this has been made possible by the generous supply of materials by our sponsor, Train-O-Matic. You can check out their products, including the products used in today's video, on their website, trainomatic.com, and also tramfabrique.nl/decoders.html. Both of those links are in the description box down below if you want to follow those to find your own products to make converting of your older split chassis locomotives possible, and indeed any other DCC fitting project that you wish to do. But until next time, this is me, Jenny Kirk, saying you take really good care of yourself. Thank you for watching. It's been great to have your company, and take care. I'd like to send out a huge thanks to everybody who supports me on Patreon, but a special thanks go out to Anthony Kidson, Michael Churchwood, Alec Ralph, Anthony Hunt, William Wade, Wayne Johns, Offshore Allen, oorail.co.uk, Tepic, Michael Lockie, and Helen Sink. Thank you. Without you guys, I couldn't do this.